Hi, my name is Kelvin. Nice to meet you. Have you ever wondered how your message, email, or even your video calls make it across the internet without getting messed up? Well, they don't always, but the internet has clever ways of catching those mistakes. One of the simplest of and the oldest method is called the checksum. In this video, you're gonna learn how Checksum works, how it protects your data, and why it's still incredibly useful even today. So, what is Checksum? As you can see, this definition is quite long, but let me explain simplest way. Imagine sending a data like a package in a mail. You want to be safe. It hasn't been damaged when it arrives. A checksum is like adding a note that says the contents of this package should weigh exactly 5.2 kg. When it arrives, the receiver checks the weight. If if it doesn't match, something wrongs. In computing, a checksum is a number calculated from a block of data. If any bit of that data changes, the checksum will probably change too. So before we deep down how it works, the checksum, we need to know what is the problem. And we have the firstly, we have type of error. There's a two single bit error and bus error. Single bit only one bit. Bus error have 2 bit or more bits. All of this caused by signal attenuation, noise, interference. Next, we're gonna talk about parity bits. Used for error detection, it is extra bit added to message from sender side to help it error detection at the receiver side. There have two parity bits. First, we have even parity bit. Second, we have odd parity bit. Never mind, let me explain a more simplest way to you. Just imagine the first two number is 1 and the back is 000 and we call as even parity bit and we gonna add up 0. But if three number is 1, 1, 1, 1 and add up is 3 means odd. So is we're gonna add up 1. Next, I'm gonna show you step by step. First is divide by data. Divide data into blocks. Add blocks. Take one complement equal to checksum. Send data plus checksum. Receiver adds and checks if result all once. Means we're gonna accept the message. So here is a simple example. So we have 4 line of numbers and we're gonna add together if and we have more than if we have more than 10 numbers, we're gonna add carry on to down there and the total up is not the final answer. We're gonna change to first complement. So it means 0 we change to 1, 1 we change to 0. And we're gonna talk about receiver side add and checks if result all once. Means if we're gonna add up all everything, we doesn't need first complement, but we just add up all equal to 1, 1, 1, 1, 1 means it's correct. We're gonna accept the message. Next is we're gonna talk about the real world happen in real life. So we're gonna first file downloads, second data backups and network communication, fourth software distribution, and fifth, database. So in these 5 key, you're gonna see in real life, like gonna happen any days in your computers when you download something and will have not download, maybe have some error because it's checksum. So next we're gonna talk about what can go wrong. For example, you can see your computer have any error like any virus or your hardware computer issue. Here's the problem lah. Example of problem: transmission errors, file corruption or update, hardware issue just like I just now say, checksum algorithm limitation, and others consideration. Some errors can go undetected. Some errors sorry. Some errors can go undetected, especially if multiple bits flip in just the right way. That's why more advanced techniques like CRC or cryptographic hash are used when data integrity mission critical. That's the end, but let me summarize this topic about. Next time you go stream a video or send a message or file or even just visit a website, you just remember a little number called a checksum may have just some your data corruption. It's not flashy, but it's one of the quiet heroes keeping the internet running smoothly. And thanks for watching. And remember, if you feel lost today, it's just a bad checksum. Thank you.